This conference will now be recorded.
To the Satellite Book Club seminar series. We're about to get underway here, and Brian Gotzel here, Office of Observations. I'm here in the room with Stuti Deshpande, who will be the speaker today. The title of Stuti's talk is Enhancing Data Quality and Maintenance in the GOES ASOS Satellite Cloud Product, sometimes called the ASOS Cloud Product, sometimes called the GOES ASOS Cloud Product. Stuti will be our speaker. She works here in the Office of Observations as well with the TOWR-S team. And our facilitator, we're glad and fortunate to have Jeff Mannion, a meteorologist from the Weather Service Central Region, SSD, joining us today. A few routine reminders. The session is being recorded. Please mute your microphone and turn off your webcam unless you're one of the speakers or facilitators. The Q&A will be, as usual, at the end of the presentation. Please post your questions in the chat with your full name, especially using your full name if you have not logged in with your full name, which we encourage you to do. As we plan ahead for future Satellite Book Club seminars, we welcome presenters. So if you have a topic that you'd like to either present on or serve as a facilitator, we would welcome you in either or both roles. Tristan, I think, is putting a link in the chat for that. To the SBC presenter form, and the training team can help you with training materials, whether it's for a Satellite Book Club seminar series or just training materials that you're seeking in the satellite area. Please contact Ross Van Til for information about that. Thanks as always to the Office of the Chief Learning Officer, the NESDIS satellite programs, our facilitator, and all of the other offices and participants. In just a few words of introduction for Stuti before we get underway with her talk. Stuti is a programmer and analyst for the TOWR-S team, working here in the Office of Observations, sitting in the same vicinity as Jordan Girth, myself, Derek, just a few floors above the rest of the TOWR-S team at Weather Service headquarters in Silver Spring. Stuti's got a background in geographic information system work and data analytics, something we'll be doing increasingly with satellite data usage and other product usage in AWIPS. Her work is primarily focusing on enhancing data management practices, and I can say that she substantially contributed to a number of our satellite projects that we're running here. So thanks, Stuti, for your work on this. Thanks for coming to the Satellite Book Club. Please take it away.
Thank you so much, Brian, and thank you everyone for being here. My name is Stuti Deshpande, and today I'm going to talk a little bit about changes made to the data used by the ASOS satellite cloud products. But first, I just wanted to say thank you so much to my contributors who helped me with this project, John Evans, A.K. Sharma and his team, Wayne Martin, and thank you to the TOWR-S team that helped me put this together. And also thanks so much, Jeff, for being here as a facilitator. Next slide. So we'll be going over some of the recent and upcoming changes to station data within the ASOS satellite cloud products, as well as some of the motivations for those changes and the analysis used for determining those changes. But first, let's really quickly cover what the SCPs are. Next slide. So you can see them here depicted to the right. The satellite cloud products are an hourly text product that provides cloud coverage estimates of cloud height and amount at mid and high levels of atmosphere. So it's primarily used for above 12,000 feet of altitude. These products are incorporated into many different products and can be incorporated into many different products. They can be used for TAF reportings, for their regional weather roundups, an hourly text product as well. They're used by pilots and forecasters and a lot of people over here at NOAA. And of course, we'd be interested in hearing if you are interested in using the satellite cloud products or if you do use them for something that we don't know about yet. And these products are produced by the imagers on both the GOES-R satellites. So let's take a little deep dive at this picture right here on the right. So as you can see, there are reportings by state. You see the state of Connecticut on here. And then those 4-letter codes are ICAO codes. They're usually at airports, but we have them for observatories as well here. Next to that is the time. Then it explains where the clouds are, what type of clouds there are. Here you can see high scattered clouds. There's also overcast, clear skies, etc. And then you see cloud top height and amount. Yeah, so next slide. So the motivation behind having these satellite cloud products actually comes from a limitation within the ASOS surface station ceilometers. So these satellite cloud products report over ASOS surface weather stations because the ceilometers can only see up to about 12,000 feet in altitude. As you can see depicted in this image here, there's a place where the ceilometers can't see past. The satellite cloud products can see everything, and they aid in reporting those upper levels of altitude. Next slide. Thanks. So the work that we did actually focuses on the station data used in these ASOS satellite cloud products. So those 4-letter ICAO codes you were seeing are in a list with pertinent information like location, elevation, active stations. And that list is used to generate satellite cloud products. We generate wherever we see a station. And previously, there wasn't really a fantastic maintenance mechanism for these stations. Updates are pretty sporadic. So let's say you wanted to add your favorite ASOS station and see it in the satellite cloud products, you kind of have to go through an email chain. There was kind of a lack of transparency in the process, and it took a while to see your product in the actual SCPs. So the maintenance just wasn't the best, and that's obviously not what we want here. We wanted to make the whole process clearer, faster, and more visible. So next slide. So we actually went ahead and changed the source list of stations. Instead of drawing from that old list of the satellite cloud products that wasn't maintained super well, we are now drawing from the better maintained and more authoritative national datasets maintenance list of stations. They had a similar list. So this is great because not only is it better maintained, in order to suggest stations, all you have to do is go on to the VLab Redmine repository and suggest a station, add station information. You can actually track that station through the review process, and you know it's going to make its way into the satellite cloud product at a specific timeline. So obviously, this took a bit of work since we were changing the stations. Sorry, next slide, please. It took a lot of analysis. And one of the things that we wanted to be really careful about is not leaving out any stations, since we're now using a new list to generate the satellite cloud products. So over here, what you're seeing in those orange bubbles are 200 plus stations that were only on the old satellite cloud product list, but they were not on the better maintained new NDM list that we're hoping to draw from, or we are now drawing from. And we didn't want to leave anything out. We didn't want a valid station to suddenly disappear. So what we did is we had a couple members of our team do a very comprehensive manual review to determine the validity of each of these 200 plus orange stations that you're seeing here. The gray is the NDM stations. And we made sure that the stations that should be on the SCPs should be visible because they're valid, got added to the National Dataset Maintenance List. And stations that weren't valid, maybe they'd shut down, maybe the IECA code had changed, something like that, were not going to stay in the ASOS SCPs. They would be removed and they would not be added to the NDM. So that might be a little confusing, so we're going to go over an example. Next slide. Oh, this is my favorite example. This is one of my favorites. This is KORC. It's in Orange City, Iowa. And the first thing we do when we look at these orange bubbles is we look into the GIS, the maps, and we see where it is. Does it make sense for there to be an ASOS station there? And here it 100% does. You can see that straight line. That's an airport landing strip. That's usually where the actual surface weather stations end up being. So we wanted to look into if that was a valid active station. So the first thing we do, top right here, you're seeing the airport information. That's from AirNav. It's a good source to see active airports and information about those airports across America. And you're seeing right here that we put in KRC and we didn't find any results. Right underneath that, we looked at aviationweather.gov, which gives like METAR data about stations, and you see KORC had no results there. And then bottom left, you're seeing the Iowa State University ASOS network reportings. They have like this excellent site that tells you what ASOSs are active and even gives you data on them. But you're seeing right there that this ASOS station was shut down in 2019. And to the right of that, bottom right, you're seeing that the actual airport was shut down. The FAA announced that in January of 2020. So obviously there is no longer a station here. This station should not be in the SCPs, should not be visible in the satellite cloud products, and we're not going to add it to the NDM list. So we know that, and that was our comprehensive review. We want to make sure we have a lot of sources, so we're being really conservative in what stations we're removing from the SCPs. We don't want to accidentally remove the wrong thing, obviously. So yeah, next slide, please. All right. So this is probably an example of the most common thing that occurs in our reviews. So ICAO codes get updated, and this is a case of an update. So you're looking now at K40J in Perry, Florida. That's the orange bubble right there. And you're seeing that next to it is that gray bubble, the gray and pink, KFPY. And they're both above the same airport, right? So this usually means that the ICAO code has been updated. And we go on AirNav and we see right there, we put in K40J and it redirects us to KFPY. You can see right there, it says formerly 40J. So 40J is not there anymore because the name has been updated. So we want to make that improvement in the ASOS SCPs as well. We don't want to keep reporting for 40J because the name has changed. And obviously, you know, it's not reporting data anymore either because the correct name is KFPY. So these are what I have been calling duplicate pairs, where they're both the same station. It's both the same station data. It's reporting over the same ASOS. It's just a different name. And there are a lot of those in this list. So that's a bit of the review we did for these 200 plus stations, and any of the valid stations that were there actively reporting data we've added to the NDM list, and they continue to be visible in the ASOS SCPs. Next slide. And then the next thing we did for more of a better data type of thing. We wanted our data quality to be great. And we decided to look for any other duplicate cases. So what we just saw on the past slide, we wanted to make sure there weren't too many of those in the NDM/SCP data. So what we did is we used a GIS tool, QGIS, to conduct a proximity analysis. We found all stations that were within about 10 kilometers of another station, or 0.1 degrees for the GIS system. And that's how you're getting these bullseye pairs of blue and pink. So those are all stations that are within about 10 kilometers of another station. We had a few hundred of those. And what we did is we did another comprehensive manual review of each of these stations to ensure that there weren't any like duplicates, same thing over different codes above the same airport, same station type of thing. And we found, in fact, that a lot of these are, in fact, duplicates. There are not that many cases where there are going to be multiple observations within 10 kilometers of each other. So we were able to use some more updated, accurate ICAO code. However, there were a few cases where there were just 2 stations within 10 kilometers of each other. We chose 10 kilometers because once you get to like 20, 30, it's pretty likely that there are airports and different stations there, but 10 and under, not so much. So I was really surprised in the cases where there were just 2 stations right next to each other. Next slide. Yeah, so this is also one of my favorite examples. You know, I made the slides. And this is in Port Ellsworth, Alaska. We have 2 stations. They are less than 2 kilometers away from each other. And I was thinking, there's no way these are 2 separate stations. I look at the GIS, they're 2 airports. You go on AirNav, 2 airports, they're both reporting separate data. So in fact, within 2 kilometers of each other, we have 2 active valid stations. And that's why the manual review was very necessary too. Alaska is one of those places where, you know, air travel is super necessary. There are a lot of airports up there, so I like the station. Next slide. And then, of course, in order to convert from one format to another, we wrote a little Python script. You can see that at the bottom. You can see a sample of it, where we converted from the format of the National Dataset Maintenance List of Stations you see right here on the left to the format used by the satellite cloud products on the right. I think if you look really closely, you can probably see Baltimore Inner Harbor on both. That should be KDMH. And you can see it in both formats right in there if it's visible. So this is a script that my team and OSPO is going to be running to update the ASOS satellite cloud products routinely. Next slide, please. Thanks. So thanks to us drawing from the larger and better maintained National Dataset Maintenance List, we have a bunch of new stations. We have 1,200 new stations and identifiers visible in the ASOS SCPs as of August 11th of last year. And we did send out an SCN about that change, and you can find this little PDF, your screenshot you're seeing right here on the VLab dataset guide page for the ASOS satellite cloud products. Also, after our conservative review of stations, we decided to remove about 150 defunct stations, so stations that had shut down or old station identifiers that had since been updated. We've removed those as of last month. We sent out an SCN for that, and you can find more information about that also on our VLab TOWR-S page for the ASOS SCPs. And another thing we included with the removals is suggested alternate stations. You can see that in the table right here at the bottom, and they're usually within a few kilometers of the one we're removing. Oh, next slide, sorry. So we made a bunch of changes to the satellite cloud products. We changed the source list. We have a new maintenance mechanism, better capable of suggesting and tracking changes. We comprehensively reviewed a bunch of stations that we were interested in. We added a bunch of stations, over 1,200, and we removed 149. But we are not done. So next. We are going to continue making improvements. And one of the improvements that I'm really interested in is removing duplicate incorrect duplicate reportings from GOES East and West. So currently GOES East and West, both satellites, report all the stations that are on that satellite cloud product list. And because some stations end up being out of view of one satellite, we end up getting a couple false clear sky reports. So there are clouds there, but the satellite can't see that far. The algorithm can't see that far, so it doesn't see any clouds. And then it's clear skies all the time. So next slide, please. I think this image does a great job of illustrating that point. So over here, we're seeing the shadows at about 70 degrees of LZA of GOES West and GOES East in blue and pink, respectively. So if you look, you can see that GOES East doesn't have the best view of Alaska. GOES West doesn't really see Maine. And because of that, they're not seeing any clouds in those areas. So when we run our SCP algorithm for this particular product, the SCPs, we're getting clear skies all the time. So if you change the slide, this is from last night where it was raining pretty badly. GOES West over Maine, right? Clear skies all the time. It's always sunny in Maine. But if you look on the right, it was clearly raining. There are overcast, scattered clouds everywhere. So we're not really getting accurate reportings, and we don't want that in our data. So if you go to the next slide, it's just back to the image. We're hoping to figure out at what point the reportings are not as accurate and then determine what states should stay. So we're looking into the science of that. And GOES West should not be reporting Maine, I don't think. But we will continue to have duplicate reportings of stations where it makes sense to have them, like the central and southern regions. So Texas, Kansas, they're going to be reported by both satellites. We just want the most accurate data possible. And we're hoping to make that change this calendar year. Keep an eye out for an SCN about that. We will have one. Next slide, please. So, excuse me. The next change that I'm going to focus on, and probably the most important change we're making, is that there will be routine updates to the station list. So, next slide. Thanks. So now when you suggest changes directly onto that Redmine repository, you know that it will be there within a known timeline, and users of the satellite cloud products can be assured that new stations are going to make it into the actual products with a known schedule. You can expect refreshments. You can expect the data to be up to date. We're looking at probably a quarterly or biannual update as of now. Alrighty, next slide. So if you have any questions, you can look up this product at our ASOS SCP page on VLab. And if you have any stations or changes to stations to request, members of the NOAA community can head on directly to the VLab Redmine repository and issue a ticket. And then you'll see those changes filter into the satellite cloud products. Next slide. Thank you so much for listening. If you have any questions or concerns, please go ahead and contact me. My email is right here, and you can also contact the TOWR-S team right there. Thank you again for listening.
All right, thanks so much, Stuti, for that interesting presentation and your work in the SCP program. I think the SCP has clearly increased our service to the public, and your work in the data management has obviously made it more efficient for field science to make changes to that list. So thanks so much. At this time, we will move into the open discussion section of the presentation. I'd like to encourage everybody to stay on for that, particularly encourage participation from the field offices as well as the regional headquarters. If you want to submit questions, you can do that via the chat, and I will read those to Stuti. or you can activate your camera and that will indicate to me that you have a question. We also encourage folks to change their view setting to active cameras from the drop-down menu at the top of the GoToMeeting so that you can see all active cameras. If you do have any feedback, there will be a link posted soon in the chat on the Satellite Book Club that you can provide feedback on that. And we also want to mention a week from today at this time, we will be joined by Rebecca Jewell, a meteorologist from Burlington, Vermont office, and she will be discussing catastrophic flooding in Vermont from about a year ago in July. We also ask attendees that you can contact the TOWR-S team, either Kashad Bowman or Emily Maddox, for questions regarding the SBC or configuration of satellite products. At this time, I'll move to the first question that I see in chat, Stuti, and that was proposed by Joe Fiore. He says, years ago, a 25,000 K algorithm to detect clouds up to 25,000 feet from the bisala kilometers was tested and showed good results. Do you or anybody in your team know if there are any plans to implement a 25K algorithm on ASOS in the future?
Yeah, I'll defer to Brian for this one.
Hey, yeah, great question, Joe. We have been in touch with the ASOS program, also part of the Office of Observations, fortunately, and the program manager, Ken Booten, confirmed that that update is still there, and there were some requirements changes in coordination with the FAA that needed to be done, but that Ken's plan is such that that should roll out in 2025. I don't think he had a specific timeline for that, like which sites at what point in time, but hopefully that will go forward next year, and that will elevate the ASOS reporting to detect clouds up to about 25,000 feet. Ken also said that they're looking at another changes in the pipeline to have some sites go as high as I think something like 40,000 feet. I don't have the number right here, but it's quite a bit higher than 25 to even capture some of those high thin cirrus clouds and so forth. So we'll keep you posted on that, and we're glad you asked that question, because how the SCP is used is, should be kind of compatible with the ASOS capabilities, so that the two products continue to be complementary. So thanks for the question.
All right, thanks, Brian. Looking to see if there's any more questions, and I don't see any at this time, so I'll ask one of my own. Do you expect a seamless transition, Stuti, when we move GOES East to GOES 19?
Yeah, I do. I think the ABI, the imager on both the satellites, are pretty similar, so there shouldn't really be a loss in data or data quality when we transition.
Okay, great. I see a question from Brett McDonald. He asks, can we include other stations besides ASOS and AWOS? There are Department of Transportation weather stations that don't necessarily report ceiling height, so he's wanting to know if those could be included.
I think if you send the specific station in for review, we will look into it and see if it gets added. We do have more than ASOS and AWOS stations, I believe, so I don't see why not.
Cool. Checking to see if there's any more questions. I don't see any right now, so maybe I'll think of another, or have another one that I could add myself. You'd mentioned grabbing data from Alaska. Could you comment more on the quality of those observations given the viewing angle that we're looking at in Alaska?
Yeah, so maybe if we go back to the image of those GOES East and GOES West shadows, I guess you can see that a lot of Alaska isn't really covered by GOES East or GOES West. And I guess I should have reiterated that the shadows we're seeing are at about 70 degrees LZA. So that's just where the image starts looking a little less crisp. It's not where the algorithm absolutely cannot see anything, and we're going in to determine a little bit more about the science of where we should stop reporting stations, but we get a pretty fair view of Fairbanks, Alaska, for example. It's about halfway through Alaska. So I do think that Goes West does a good job there.
Okay, great. Still not seeing any more questions at this point, so I'll try one more. And it's one I had as I was reviewing your presentation, and I think we may need to go to your team for this one, but I believe we're using a multispectral approach to get the data for the SCP. So it's not just relying on the channel 12 or channel 13 infrared. So for instance, during cold outbreaks, during Arctic outbreaks, you'll see on the satellite that the very cold temperatures. It kind of looks like it's cloudy, but you have to go to another channel to determine that it's truly not. So are we using, have you had any false cloudy reports? You have mentioned the false clear ones. Do you know if we've had any false cloudy reports? Or is the multispectral approach helped with that or solved that?
Cool. We're wondering if AK or someone from the NESDIS algorithm team might chime in to help us answer that question.
Yeah, we have seen the faulty cloudy cases as well in the past. So I would say multi channels, but it might need some more improvement in the algorithm, I would say. We don't have a sounder. This is all emitter. So you know that this previously we derived this product using the sounder, but now we only have limited capability for emitter. So that's the limitation.
Okay, thank you.
Welcome.
At this time, I don't see any more questions, and unless I have missed something, I think we'll hand it back over to Brian to wrap us up.
Thanks. Thank you, Jeff.
All right. Your microphone's on, right? Yeah, great. Thank you. Sorry about a little bit of logistics here. Thank you very much for this presentation, Stuti, and thanks, Jeff, for your facilitation. AK, we will be reaching out to you to delve further into those questions about whether we could add additional sites. And most of that work is actually on your side of the interface. Of course, we can make the changes on our side to accommodate them. But so we can explore that with you further if folks want to submit more stations based on the link that Stuti provided in her presentation for doing so. And contact Stuti directly if you need any help with that. And then we are certainly working to make sure there's a smooth transition on April 4th between GOES 16 and GOES 19. AK, if we're hoping that the GOES 19 algorithm will be ready to go day one along with the other algorithms, so we'll have a smooth transition across the GOES 16 to GOES 19 changeover next April.
Yeah, certainly.
But anyway.
Yeah.
Okay. Thanks, AK. We'll be in touch about that.
Sure. We plan to do that. Yeah. Anyway, it's in our plan.
Okay. Yeah. Terrific. And by the way, one thing I did want to add is some of the reason I think for the redundancy in the stations had to do with the transition between GOES 13 and GOES 16, the first in the GOES R series, and then GOES 17. Is we have to do some wild and crazy things to deal with the lack of a sounder and the different imager, so I think there's a chance to undo some of that redundancy that was put in, which was useful for a while, but now is probably not useful. In fact, I think we could improve the project to get rid of some of those products, as Stuti alluded. So thanks again, Stuti. Thanks again, Jeff. We appreciate all your participation and welcome your feedback. As Jeff told us, join us next week on July 25th for Rebecca's talk on the July 2023 year-ago flooding in Vermont. Look forward to seeing you then. Otherwise, we're signing off here. Have a great day.
Thanks for coming.